Hello, I'm Dr. Marie-Noël Cajada.
Hello, I'm Dr. Nicolas Bonnet.
We are scientists in bone physiology at Nestlé Research Center in Lausanne.
We are here today to discuss how the gut can influence bone health through the communication with the gut microbiome. It is called the gut-bone axis. Did you know that gut is a key organ that constantly interacts with the skeleton? 100 trillions of microorganisms reside in the gastrointestinal tract. They weigh up to 2 kilograms and form the gut microbiome. This microbiome interacts both directly and indirectly with their host, playing role in normal biological processes such as nutrient absorption, metabolism, and growth. It's now becoming clear that the gut microbiome is also an important factor in the development and maintenance of healthy bones, specifically to regulate the absorption of nutrients required for bone formation, such as calcium. That relationship forms the gut-bone axis. The intestinal bacteria consume and digest nutrients like protein, lipid, fibers, which leads to production of bacterial metabolite. These are the well-known short-chain fatty acids, for example, butyrate, propionate, and acetate. What do we know about the mechanism of action involved? Today, only preclinical data document them. Indeed, these metabolites have been reported to stimulate the activity of osteoblast and osteoclast cells that are responsible for building and maintaining bone strength respectively. They decrease the gut pH, which improve mineral absorption such as calcium, as well recognized nutrient for bone development. Probiotic can also control secretion of gut hormone such as glucagon-like peptide, GLP-1, that also participate to other nutrient absorption through the control of food intake. Finally, immune cells are also impacted by the bacterial metabolite and will secrete anti-inflammatory cytokine that can increase bone formation in one part and decrease bone resorption, leading to strengthening of the bone. So there are two ways to modulate this mechanism. Either you provide substrate that will impact bacteria activity or abundancy, and there is the example of prebiotic, or you directly provide bacteria in the food, which is called the probiotic. But let's deep dive first into the bone physiology and how nutrition can modulate its metabolism. The bone is a dynamic and highly specialized connective tissue that provides mechanical strength for muscular activity and physical protection to internal organs, as well as a reservoir for minerals such as calcium. Bone mass evolves throughout life, including the whole childhood and adolescence, which are identified as periods of rapid bone growth, followed by high bone mineral accretion that peak shortly after reaching adult height gain. During childhood, the skeleton is particularly vulnerable to fracture, with an increase of incidence of fracture starting from the age of 2 and reaching a plateau around 6 years old. It was reported that children who have fractured before the age of 4 will fracture again throughout life, independently of falls and physical activity. Therefore, childhood represents a critical window for maximizing peak bone mass, optimized bone strength, and lifelong bone health. Interestingly, you will note that bone change evolves in parallel with the gut microbiome trajectory, suggesting a clear link between bone and gut health.
What are the main determinants of bone health? Genetic is the main one, but nutrition is also an impactful influencer, such as calcium, phosphorus, and magnesium, vitamin D, K, C, and, of course, proteins mainly. Finally, keep in mind that bone health is also maximized by physical activity. As you all know, calcium and vitamin D are key to ensure healthy bone growth or limit the bone loss. Adequate intakes or supplementation allow a gain in skeletal mass and density in children and adolescents. As an example, supplementation can lead to a 5% increase in bone mineral density. However, even if deficiency in these nutrients has been associated with poor bone health, it's also recognized that their sole supplementation is not enough to improve bone strength. More recently, it was suggested that adequate vitamin K2 intake is needed to transfer calcium from the blood to the skeleton, complementing the role of vitamin D in intestinal calcium absorption purpose. Now, let's focus on other nutrients that have now been identified key in bone health: prebiotics and probiotics. Prebiotics, such as fibers, fructogalacto-oligosaccharides, FOS and GOS, inulin, as well as human milk oligosaccharides, HMOs, so-called, can be either provided as supplement, fortified food, or are normally occurring in foods. The ones called HMOs are naturally present in breast milk or also some formula. Concerning probiotics, on top of the one hosted in your gut microbiome, they can also be found in breast milk, dietary supplements, fortified food, infant formula, growing up milks, or present in fermented products such as yogurt, kefir. Some probiotics, such as L. reuteri and L. rhamnosus, and specific prebiotics, such as GOS, FOS, HMOs, may modulate bone growth and strength. When they are both combined, they produce short-chain fatty acids, which are improving calcium absorption via a pH reduction. One randomized controlled trial in adolescent girls demonstrated that in less than 3 weeks of GOS consumption in 2 milk-based smoothies per day, calcium absorption was significantly increased when compared to the control. Similar results were observed in only 9 days in adolescent boys with oligofructose supplementation. One trial done in kids with inulin intake during 12 months showed that improved calcium absorption translated into a significant increase in whole body bone mass density and bone mineral content, around 48 grams at the end of the study. And in one randomized controlled trial, it was shown a positive impact of tibia bone mineral density after 1 year of L. reuteri supplementation in elderly women compared to the control group. So, concerning intervention with probiotics or symbiotics, until today there is no clinical data existing in kids that would assess their impact on bone growth and strength. However, very recently at Nestlé Research, we were the first in generating new clinical data showing the efficacy of a growing up milk containing a symbiotic, GOS plus L. reuteri, on toddlers in bone strength. That kind of clinical evidence highlights the relevance of such nutritional strategy, including targeting the gut microbiome to support the gut-bone axis. In conclusion, a healthy gut microbiome maturation in childhood is really key to support bone health. Modification in the gut microbiota composition and host responses triggered by dysbiosis might contribute to pathological bone loss. Actually, changes in microbiota composition that prevent or reverse bone loss can be achieved by nutritional supplements with specific pre- and probiotics.
So, throughout this video, you got the key take-home message. The first one is that adequate intake of calcium, vitamin D, and vitamin K is key to support bone health. But
new nutritional factors can now help further the bone mass acquisition, like prebiotics, probiotics, symbiotics, thanks to the gut-bone axis communication pathway. Thanks a lot for listening to us.
thanks.